Now to posit that in physics, every mathematical structure has a corresponding physical reality, it's like mixing up the fields of mathematics and physics. And it's ignoring the fact that we exist in one amazing, special, beautiful universe and saying, no, this is just one thing, but there's everything possible exists because it's true in mathematics.
ID, the Future, a podcast about evolution and intelligent design.
The laws of nature that govern our universe are finely tuned to allow for life like us. But have you ever wondered why these laws govern our reality and not others? What is special about them? And what would things look like without them? Welcome to ID the Future. I'm your host, Brian Miller. Today I continue my conversation with mathematician Ellie Feder and physicist Aaron Zimmer, hosts of the Physics to God podcast, to discuss their recent work explaining the uniqueness of the laws of nature. Gentlemen, welcome back to the show.
Thank you, Brian.
Thank you. Pleasure to be here.
Now, in the first half of our conversation, we discussed how the structure of the laws of nature appears to be designed for life. And you also talked about the advantages of each particular type of argument, the structure of the laws, and the fact that they're fine-tuned. Today, we'll talk about attempts to argue that the laws are not the result of design. So let's begin by discussing how do scientists attempt to explain the life-friendly nature of the physical laws?
Okay, so there's really one attempt of a scientist to explain why our universe is governed by these laws as opposed to any others. And that is it's a multiverse solution. And it's by a guy named Max Tegmark. He's an MIT physicist. And his explanation is kind of out there. It's like a wild explanation, but his basic theory is he calls this the ultimate ensemble, or the
Mathematical universe
hypothesis. And his basic theory is that he calls it the level 4 multiverse. And he starts with an equation between math and physics. And he says that math is the same thing as physics, and everything which is mathematically true is physically true. In other words, he says, why should it be, for example, in math, and this is true in math, that you can make up any laws, any set of laws, and they all work out in math. In the world of mathematics, anything works. But he says in physics, why should there be only one set of laws which governs our one universe? There's a theory you could have imagined a universe by any set of laws. So he says there's a mathematical democracy, if you will. And he says every single possible set of laws actually is real. It actually governs the universe. And there's this infinite multiverse where every set of laws exists. So quantum mechanics, general relativity, there's one universe which operates according to that, but there's other universes which work by mathematically consistent magical spells. And there's other universes that work. Every single possible set of laws that you could come up with exists. And we obviously are going to exist, and then you have like an observer bias. We obviously are going to exist in the universe with a set of laws which is conducive with life. And that's how they explain, why do we have these special laws? Because given that all the possible laws exist, we obviously can only exist in a universe like our own.
I feel like I'm watching a Marvel movie with Doctor Strange. I think I can see how this has inspired these different movies. Now that's quite a bold claim. Does he actually present any evidence to support this idea?
Okay, so basically his evidence is it's more of an argument where he says it would be nuts if only one set of laws were to exist. Why should it be that their only reality is a universe with gravity and quantum mechanics? Why aren't there other universes with other laws of nature? They're logically possible. Like, what selects them? And basically, he doesn't say this explicitly, but it's implicit behind him. Behind this theory is that there's really three possibilities. Either nothing exists, everything exists, or something exists. So if nothing exists, then you don't have to explain. There's nothing arbitrary about nothing, but obviously it's not true. Something does exist. There's a universe. So there's at least one universe, you got it. So basically, you're either left with saying everything possible exists, and then there's nothing arbitrary. But if only something exists, like one universe with gravity and electromagnetism, then you have this problem of why do these laws exist, nothing else? So his basic evidence is that it would be crazy if the only universe that existed is ours, because what selects that this is the only universe that's real, nothing else? So therefore, he says everything possible exists. Every mathematically consistent law exists. And, it would be crazy to say 2 plus 2 equals 4 exists, but 3 plus 3 equals 6 doesn't exist. That would be crazy. Those are perfectly equal equations. None of them is more real than the other. So too, every possible theoretical law in the universe is real, governs a separate universe. And his evidence is it would be crazy for it not to be true. So therefore, it must be true that we live in an infinite multiverse where every possible law exists.
So it sounds like it's not so much on hard data, but more this intuition he's coming with, is if that would be
Yeah.
fair.
Right. There's no real hard. How do you have hard data for unobservable universes? There's no hard data for.
And now, do you find problems with his proposal? Are there issues that you've identified?
Yeah. So the problem, besides the fact that it's making up that all these universes exist, is the question is how does he attempt to explain our particular universe? And the way is that it's based on an appeal to an observer bias, right? But there's something is like when you want to appeal to an observer bias, you're trying to say is like this would be the typical universe that an intelligent observer would find himself in. If you really have infinitely many universes, you could really explain anything possible. There's nothing which you could observe that you can't explain. For example, he said, if you hear a voice coming from the sky that says, I am God and there's no multiverse, you say, well, we're in a universe that happens to occur. So there's nothing that you can't explain. You could explain all of life by just saying we happen to be in a universe where there's life. You don't need evolution, you don't need anything. So
Multiverse of the gaps, because if you explain everything, you explain nothing. You're not explaining anything by saying everything possible exists. So of course, you could have said that without observing the universe. It's just a multiverse of the gaps. It's not a very good theory.
right. So what makes multiverse, what in theory would make multiverse into a rigorous theory, is if you could say that our universe is not just any old universe, but this is the typical universe that an intelligent observer would find himself in. And then you could really invoke an observer bias to explain our laws. We have our laws because this is the typical way that we would expect an observer to find himself in. But if we would hear a voice from heaven, we can no longer appeal to an observer bias because the typical intelligent observer would not expect to hear a voice from heaven. Therefore, the voice in heaven would be an indication of an intelligent voice, a God. But again, their claim is that our universe is a typical universe that an intelligent observer would find himself in. And the problem is, and this is the problem with all multiverse theories, but it's even worse for Tegmark's multiverse. The problem is it doesn't quite seem true. It doesn't seem from the set, and Alexander Valenkin pointed this out, it doesn't seem that our laws are especially simple and beautiful. And there seem to be many more complex ways to produce intelligent observers. It seems like if you want to know, there's a lot of different complex laws that could result in intelligent observers and not as many simple, beautiful laws that could result in complex observers. And therefore, it doesn't seem like our universe, our laws are really the typical way to get intelligent observers in an infinite multiverse. And that's a problem with his theory because if our laws are not the typical way to get intelligent observers, well, then you're dealing with a multiverse of the gaps. Then you're not really appealing to chance to explain our universe because chance would predict that we would have intelligent observers in a complex universe. And in fact, our laws are not complex, they're very simple. So that's like, in a certain sense, the beauty and simplicity of our laws is like a counterexample or falsifies the prediction of a multiverse theory that our universe would be a typical universe with intelligent observers.
Yeah, and that is an absolutely brilliant argument because, again, if you just think about fine tuning and you argue from multiverse, you could say we just got lucky. Our universe supports life. But from what I hear you're saying is that even if you stick to just universes that support life, and you look at this ensemble of universes that support life, then our universe is highly, highly unexpected even if you just look at universes that support life. I think that's absolutely brilliant.
Physicists say this. It's not really it's argument, but like Alexander Vilenkin calls the principle mediocrity. Brian Greene writes about it. Like most people don't appreciate that point, but like the top multiverse scientists, they understand this idea that you can't just say anything happens if everything exists and then some of this happens. You have to show that your theory predicts that we would observe a universe like our own, and that's where multiverse runs into a lot of trouble.
Now, is Tegmark aware of this issue? Does he try to address this problem in any way?
Yes, he does. His Tegmark, he's a brilliant person. Again, what's so amazing is these physicists, they're brilliant people. So they don't miss these points. So what he does is he does like other multiverse theories. He comes up with something called a measure. Okay, so a measure is a rule that a physicist comes up with. It doesn't, where you basically find a way to count the universes or to order the universes in ways where, even though there's an infinite number of every single type of universe, you have a way of measuring them and figuring out which one is more probable according to your rule. It's kind of measures are we discussed this on the Physics Got podcast. Measures are they're not really good solutions. Physicist Paul Steinhardt really wrote a scathing article about it, and a lot of physicists don't like measures because they're ad hoc. They're not part of. They don't emerge from the theory itself. They're something that a physicist creates and imposes on the theory. It doesn't change the multiverse, whatever measure you're using. It's just your rule for how to measure and arrange the multiverses in your head, so to speak, is changing based upon your different measures.
Let me just explain a little bit. So the idea of how the measure would help is basically what Tegmark proposes is that even though there are infinitely many universes in the multiverse, there's somehow more simple universes than complex universes. There's more, even though they're all infinite, there's this idea of making a measure, which is this organizational system, which makes it that there's almost like a penalty for complex universes. And complex universes are, so
Complex
to speak,
laws.
for complex laws, there's like a penalty such that those aren't so frequent. And simple laws are going to be more frequent. And there's this, he posits that there's this measure which over on top of the universe, which governs the frequency of different universes, and says that even though they're all infinite, it's going to be much more common or likely to get a universe with simple laws than a universe with complex laws. And given this measure, which, as Aaron was talking about, is ad hoc and making it up, then the claim is our universe is the typical way to get intelligent observers.
And you've talked about this measure problem before. Could you just sort of remind us of what the problem is with that response, and also how it also relates to Tegmark's ideas?
Okay, yeah. So the measure, again, it's like a meta law. It exists outside of the laws of nature themselves, and it's created by physicists. A physicist decides, because I have an infinite number of every possible universe with every possible law. So he's going to make up some sort of measure and posit there's a meta law that transcends the laws of nature and selects out which laws of nature are more probable than others. And the problem with it is that it's almost obvious. It's just this ad hoc addition that a physicist comes up with. It doesn't emerge from gravity or quantum mechanics or string theory, eternal inflation. It doesn't emerge from any known physical law. It's just something that a physicist comes up with in order to make up a rule, in order to compute probabilities. Because if they can't compute probabilities, the multiverse doesn't work as a theory. So they need to compute probabilities. And it's ad hoc, and the measures they come up with don't really work. And the measures are, in general, they're fine tuned because they tried out 100 simple measures. The measures don't work, so you have to come up with these ad hoc constructed measures, and you end up with the same problem of who fine tuned your measure, as opposed to who selected these laws of nature. It's who selected the measure, which tells you the rule is simple laws of nature are more common than complex laws of nature. So you end up with this asymmetry in the very measure that selects which laws of nature are more common than other laws of measures.
And the major problem, just to add on, is that this is what Aaron's been describing is the problems with measures in general. They don't work then, and
For any multiverse theory.
for any multiverse theory. They don't work, and they're ad hoc, and they end up having to be fine tuned. But there's a especially unique problem which exists for Tegmark's multiverse theory itself, which doesn't apply to the other one, and Vilenkin makes this point as well, is that the idea of Tegmark's level 4 multiverse. He says that there can't possibly be another multiverse because his multiverse is supposed to be the multiverse of all multiverses. Every possible set of laws which you could imagine exists in this multiverse. And there's none others. It's by definition exhaustive. It includes every possibility. But yet Tegmark is claiming that this multiverse is governed by a particular measure, which makes it that universes with simple laws are more frequent than ones with complex laws. But now that measure itself should be within this set of laws. And he's saying that, what about the other measures? There should be another measure which works the other way. And how does it even make sense to say that this measure actually exists and not some other measure? According to his theory, all measures exist, all laws exist. There's no sense in saying that our multiverse is governed by a particular measure. That's against this whole theory of the democracy of mathematics, is that everything possible has to exist. So how could you suggest, in order to solve the problem, that our multiverse works by one measure? What about all the other measures? They should equally exist according to his very theory.
That's a profound argument. In fact, I remember in our previous conversation, you talked about the inflationary model or other standard models of a multiverse, and how those models actually would suggest that the universes with what are called Boltzmann brains would be far, far, far more common than our universe. That younger universes are actually much more likely, where random fluctuations produce a brain. So that was I love that argument. And then you're saying now that with Tegmark's model, it's even worse because you could have an infinite number of measures. So how can you possibly justify choosing one measure as having a priority? That's really profound.
Right, and that's
Now,
his whole motivation is he doesn't want to have any symmetry where
Asymmetry.
and asymmetry where one law of nature is more real than another. But he ends up in the end of the day positing asymmetry in the measures, the meta laws of nature, where there's one meta law that's real and a bunch of other meta laws that are not real. And he just undermines, like self defeating. His whole motivation is undermined by the fact that he has to accept that one meta law is real and the other meta laws are not. So it just destroys itself.
so what you've essentially shown is even on his own terms, his model is logically incoherent and
Yes.
inconsistent with what we observe about us. But are even the premises of the mathematical multiverse reasonable? Do you even agree with this premises?
No. No, to say simply is it just seems to be like, I'm a math guy and Aaron's a physics guy. And they're different fields. In mathematics, it's true. You could invent anything and call it mathematics. You could study three-dimensional manifolds or four-dimensional or five-dimensional or six-dimensional. There is a democracy of mathematics. Whatever axioms you want to make, there's Euclidean geometry, non-Euclidean geometry. It's all in your head, so to speak. You can make up whatever axioms and see what happens. But that's not physics. That's mathematics. Physics, you're dealing with a universe where we have observations. Science is based on looking around at the universe that we observe and discovering the laws that govern our universe. And just to posit that because in mathematics, in this abstract world of mathematics, everything is equally real. Now to posit that in physics, every mathematical structure has a corresponding physical reality. It's like mixing up the fields of mathematics and physics. And it's ignoring the fact that we exist in one amazing, special, beautiful universe and saying, no, this is just one thing, but there's everything possible exists because it's true in mathematics. It's like it's mixing categories, mixing up the frameworks and the studies of mathematics and that of physics.
I think part of the confusion comes from the fact that modern physics is like always written in the language of mathematics. And you open up a physics textbook and all you find is equations and mathematical symbols. And to some people, that makes them think that mathematics and physics are the same. But but that's just it's wrong. It's a mistake. It's surprising to see Tegmark make that mistake. But because the great physicists, Einstein, Feynman, Galileo, they speak about how special mathematics is for physics because it's the language in which physical theories are expressed. But mathematics is a special theory. I Feynman point out it's a language with logic built into it. Well, it's just a language for expressing physics. It's not that the universe is mathematics itself. It's the universe is something that we observe and we experiment with and we try to describe through science. What we're describing are one particular reality. And mathematics is the language of describing it. It's just a big mistake to destroy all the truth that science has ever discovered and say there's nothing special about Einstein's equations. Those are every possible law is real. You just destroy universal laws. There's no objective reality. It's really a very destructive whole Tegmark's theory that every possible law exists. It destroys objective truth. It makes the universal laws of nature non-universal, just our particular rules of our local neighborhood, and it really undermines everything science is based upon.
Oh, yeah, that makes a lot of sense. Now, how would you describe the proper relationship between math and physics? And how would this asymmetry that you're alluding to relate to your argument for design?
Right. So again, as Aaron was saying, is that the physicists describe the mathematics as the language of our universe, and our laws are written. I think Galileo has a quote like that also, like the beautiful the language in which our laws are written is that is mathematics, and the laws of nature are formulated are there are one set of laws of nature, but they're formulated in the language of mathematics. And when we study these laws, the one set of laws which we discover and we analyze and we try to formalize, when we look at the nature of these laws, as we talked about last time, we discover that they are designed, that they have these unbelievable features which are unique in their ability to produce atoms, stars, molecules, planets, galaxies, and life. And that's both in their qualitative nature and in their quantitative nature. Well, I guess we're focusing here on the qualitative nature, but given that, again, these set of laws which we do discover in our one universe are unique in their capacity to result in our unbelievable universe, we think that our one universe with its one laws point to one God, or one intelligent cause of those laws, as opposed to saying we see one universe and we posit infinitely many universes in order to explain the beauty of our one set of laws. It just seems to be, you know, just totally outside of what we observe, and it's just kind of making up a whole set of mathematical multiverse in order to avoid the clear indication in our one universe of our beautiful laws, which point to an intelligent cause.
Okay, that was beautifully said. Now, as we close, I have one final question. How can people listen to the Physics to God podcast and find more about your work?
So, you can listen on any podcast platform, Apple or Spotify or any other one. We're available on YouTube, Physics to God channel, and our website, physicstogod.com. You can find all our episodes in essay form. We have, we have it in like long form and we have it in short form, series of like 10 short videos and summaries. So this really depends on how much a person really wants to delve into these areas. If you listen to the full seasons or listen to summaries just to get a basic idea, because it is the arguments can be summarized and a person can walk away with a pretty clear idea on why physics points to God. But just by going through the area, beyond just seeing that, okay, I could see that there's an intelligent cause and God exists, but it also, by going through these seasons of the Physics to God podcast, you can really see the wisdom of God and the intelligence of God in the universe. And it's kind of amazing how much physics, modern physics, you'll learn just by investigating, does the universe have an intelligent cause or not? You end up really getting a good perspective on the entire, framework that modern physics sets up. And it really exposes you to the real infinite wisdom that is in God's creation.
But on our podcast, Aaron, we have this back and forth where Aaron is explains the physics in a clear but sometimes complex way, and my job is to use analogies and to break it down and to simplify. And if any of these ideas seemed a little complex, we were kind of pushing it into a quick interview. But we really develop all these ideas in much more depth, careful, slow, spell out
Well, you
everything,
don't need to
explain
know
everything.
physics because Ellie explains that.
Yeah, exactly. So that's, we try to, so we have, again, we're trying to be rigorous, but at the same time accessible. So if any of your listeners were scared off by, or some parts they didn't follow what we were talking about, it's Aaron's fault. But, you can check out the podcast and you'll see it's, I think we really make it. We take a lot of effort to really try to spell everything out in a way that everybody can understand.
Yeah, and I've thoroughly enjoyed the podcast, both because it does have scientific rigor, but then it also is very, very accessible. And the conversation between you two, I think, is really unique. So I encourage our listeners to to keep listening to it. But again, thank you so much for your time in allowing me to interview you today.
Sure, our pleasure.
Our pleasure as always, Brian.
Now, for our listeners, if you missed part one of our conversation, be sure to go back and check it out. And for ID the Future, I'm Brian Miller. Thanks for joining me.